Hi, in our previous video, we've covered ISLM model with general functions. So now we are moving to ISLM BP. As I told you before, due to the fact that we are using now general functions, all calculations of comparative static derivatives are going to become way easier. However, at the beginning, we of course need to do some groundwork to derive every element of the method. And let's start, as always, with IS curve. Look, here, actually, as you see, the setup is almost identical as in the previous just ISLM model, except we are adding current account. Current account is simply net export. And here you see, we are assuming that current account have two determinants. First one is exchange rate. Look, we already said that assuming that exchange rate is defined how many units of our currency we need to pay for 1 unit of foreign currency, right? In this case, higher exchange rate means depreciation, right? And with depreciation, we know that our goods are becoming more competitive, and because of that, current account improves. So, based on that, we can say the partial derivative of current account with respect to exchange rate is positive. So, the more we need to pay for 1 unit of foreign currency, the better should be our position in the current account balance and net trade. Of course, current account has a second determinant, which is GDP, so income. Now, here we're actually talking about MPI, marginal propensity to import. We're going to denote this as CAY, and we know that this must be lower than 0. And look, because this is MPI, right? So we can say the absolute value of this should be between 0 and 1. But this is not the most important thing. The most important thing are those two relationships. We know that actual depreciation improves current account, while higher GDP, due to the fact that we spend more money on imported goods, has negative impact on current account. Okay, carrying on, this is truly the only new thing we've got here in comparison with ISLM BP, with ISLM model. We of course remember that derivative of consumption with respect to disposable income, which we are denoting C prime, is our marginal propensity to consume, and it's somewhere between 0 and 1. We know that the derivative of taxes with respect to income is a tax rate which is also between 0 and 1, and we remember that in order to differentiate this expression with respect to income, what we need to do is to use the chain rule, right? We know that over here, the intermediate step between income and consumption is disposable income. So we get that this is equal to C prime times derivative of disposable income with respect to income, which is 1 minus T prime. And we know that it also needs to be between 0 and 1. Okay, so look, just as before, we need to condense this system into just one single equation that is going to be now, first thing we should do, knowing that this is our new IS curve, is to try to estimate its slope, right? So, first thing we do, of course, is that we differentiate this expression with respect to income and interest rate, right? In this space, we are actually drawing the IS curve. Okay, so how does it? We've got dy equals to c prime times 1 minus t prime dy plus I prime. Oh, that was one thing I haven't said, but it's just like we had in the previous case that, of course, derivative of investment with respect to interest rate is, of course, negative. The higher the interest rate, the lower now. Okay, so we've got I prime di, then we've got plus nothing, right? Because this doesn't contain either income or interest rate, and out of this one, we've got income over here. We will have that this is CAY dy. Okay, and look, let's do it like that. Let's put all the expressions with y on the left-hand side, and everything else let's leave on the right-hand side. So we've got 1 minus c prime, 1 minus t prime, minus c a y dy equals to I prime di. Now, dividing both sides by dy and I prime, we get that di over dy is equal to 1 minus c prime times 1 minus t prime minus ca over I prime. Now, what do we know about it? What do we know about it? We know that this part is somewhere between 0 and 1. We know that this expression is negative. Consequently, minus and minus gives us plus. We know that the upstairs is positive. And finally, this derivative is negative, so positive and negative gives us negative. We know that IS curve is going to be downward sloping. So in the income interest rate space, the IS curve is going to be downward sloping. So now we move to LM curve. And actually, LM curve is going to be no different than the one that we had in case of ISLM model with general functions. But as you remember, I hope you remember, we had exactly the same situation when we were dealing with linear model, so it shouldn't come as a surprise. So we've got money demand equals money supply as equilibrium condition. Money demand is given as Ly, where we know that derivative of money demand with respect to income, which we define as Ly, is positive, while derivative of money demand with respect to interest rate, which we define as Li, is lowercase. And again, we are also assuming that money supply is given by get that the entire model could be condensed into one equation, and in order to get slope of LM, we need to differentiate with respect to income and interest rate. So we get Ly dy plus Li di equal to 0. Once we rearrange it, and divide both sides by dy and Li, we get the slope of Lm, which is equal to negative Ly Li. We of course remember that because Li is negative, Ly is positive, we've got minus in front, it must be bigger than 0. Now, we are finally ready to add LM curve to our graph. Okay, and finally, the only curve left we've got is the BP curve. We already discussed final points of it when we were discussing the linear model, so it also should go pretty fast. But now we've got balance of payment curve. And balance of payment curve is defined in a very similar way that we had it with the linear model. This is a sum of current account and capital account. But let's denote this capital account K, because there would be again too many things. Of course, if exchange rate is supposed to be in equilibrium, those two must be closing at 0. Now look, we redefined CA already as a function of exchange rate and income. We already established that the two derivatives are CAE, which is positive, depreciation improves current account, and CAY is negative. Higher income means higher imports and worsening of trade balance. However, now we've got also capital account function, and similarly to what we had previously, capital account is going to be a function of domestic and world interest rate. And look, here again, we need to define appropriate derivatives. So, partial derivative of capital account with respect to interest rate, which we will denote Ki, must be positive. What does it mean? If interest rate in our country goes up while interest rate remains the same in the rest of the world, our assets become relatively more attractive, and people from the rest of the world would like to purchase our assets, so they will need to purchase our currency in order to purchase our asset. So our country actually experienced capital inflow. And look, reverse must hold for the world interest rate. It needs to be negative. Why? Well, while holding now domestic interest rate constant, if world interest rate goes up, it means that foreign assets are becoming more attractive. Now, home residents, domestic residents, need to purchase foreign currency in order to purchase foreign assets denominated in foreign currency. So we will see capital outflow. Okay, and look, this is enough for us actually to handle BP curve. So now let's calculate the slope of BP. Well, we differentiate it with respect to income and interest rate. So we get that this is CAY dy plus KI di equals to 0. Again, we move this to the other hand side. We divide both sides by dy and ki, and we get the slope of BP to be negative CAY over KI. Now, KI is positive, CAY is negative. We've got minus up front, so this expression must be positive. So look, we've got the third curve, the BP curve, that is upward slope. However, let's notice one thing. We've got two curves that are upward sloping, LM and BP. So why did I draw it like this? Well, I draw it like this because, let's just say, in reality, high capital mobility is something that is true for most countries. So BP is generally flatter than LM. However, now that we are able to analyze this model using simpler arithmetics, because we use implicit function rule, and it's easier for us to calculate comparative static derivatives, we will be able to actually assess what happens if BP is more steep than LM. But this a little bit later. Okay, our next step is, of course, to assess the complete model. Okay, so we're going to have three curves. First is going to be IS curve, where this is a function of three endogenous variables: income, interest rate, and exchange rate. And in our case, this is also a function of three exogenous variables: government spending, money supply, and world interest rate. Now, how should we write it? Well, we need to express it as equals to 0. So we use the equilibrium condition, and we write it as y minus c yd minus I minus g 0 and minus ca e y. And this equals to 0. Okay, then we need to take care of LM curve. We also treat it as a function of income, interest rate, exchange rate, and three exogenous variables G0, M0, and I. Now, here's the situation. Simpler, we've got just L, Y, I, minus M0 equals to 0. Now, finally, the BP curve, which we also write as a function of income, interest rate, and exchange rate, three endogenous variables and three exogenous GO, M0, I, W, and it's equal to C, A, E, Y, plus K, I, W, equals to 0. So, now, what is the first thing we are doing in this case? We need to see if those three functions are actually defining an implicit functions of exchange rate, income, interest rate, and exchange rate as a functions of exogenous variables. Now, so we need to calculate the Jacobian, right? and if Jacobian is different than 0, then we know that this is true, and we know that the equilibrium in the model that we want to analyze exists. So, again, we start by calculating the Jacobian, and again, how do we do it? Just like we did before. Remember, here we've got first function, second function, third function. We need to differentiate them with respect to endogenous variables. So first we differentiate with respect to y, then with respect to I, and then with respect to E. So income, interest rate, and exchange rate. So let's go. Out of the first one, if I differentiate with respect to income, I'm going to get that this is 1 minus C prime 1 minus T prime minus CA y. Okay, I'm going to make it bigger. Okay. Then, if I'm going to differentiate the first equation now with respect to interest rate, I'm going to get negative I prime. And with respect to exchange rate, I'm going to get negative CA E. Okay, then we're going to do it for the second equation. If I'm differentiating it with respect to income, I'm getting LI. Interest rate, I, exchange rate, 0. There's no exchange rate there. And again, now we differentiate the third equation with respect to income, so we get CA, Y, interest rate, KI, and exchange rate. Again, CA, E. Okay, and this is our Jacobian that we need to calculate. And let's notice a very simple thing. First thing I can do with this Jacobian is I can take CAE out. Remember, this trick is very important with all the calculations and makes everything simpler. Okay, so we've got 1 minus C prime, 1 minus T prime, plus minus CAY. Now minus I prime minus CAE, and insert minus 1. Then we've got LY, LI 0, CY, KI 1. Okay, and the best way to do it actually is to use Laplace expansion. Okay, so what do we get? We have CAE in front, we open brackets. Okay, so I'm going to expand it using the last column. So this element, first row, so we got just negative 1 in front of, if I'm deleting first row, third column, this. So we got LY, LI, CAY, KI. Okay, and then there is this element, it's just 1. It lies in the third row, third column, so we don't change the sign. And we multiply this by 1 minus C prime, 1 minus T prime, minus CAY, minus I prime, LY, L. Okay, so now we can calculate this all the way through, and we get negative, and then this is negative LYKI minus CAY LI. But there's minus up front, so it's plus, right? Minus, minus, plus, plus. Okay, now we are dealing with this part, so we've got plus 1 minus C prime, 1 minus T prime, minus CAY times LI, and now plus LY times L. Okay, and this is, look, we can easily see that here we've got Those cancel each other out. And we see that both of those have Ly. So we can put them together. Okay, let me just finish this over here. And based on what we calculated, we get CAE and now times 1 minus C prime, 1 minus T prime times Li plus Ly times I prime minus Ki. Okay, so now we have found the expression for the Jacobian. We need to assess its sign. We know that this is between 0 and 1. We know that this is negative, so those two together are negative. Now look, this is positive, this is negative, this is positive, however it has minus up front, right? So this is negative times positive, this is also negative. And CAE is positive, right? The depreciation leads to improvement of current account. So we know that the Jacobian is lower than 0, and because it's lower than 0, it's different than 0. So because we know that the Jacobian is different than 0, we can proceed with our model. And look, what do we get? First, we can finally write that those three curves intercept at one given point, and on the graph, this point is going to give us equilibrium in income, interest rate, but also exchange rate that we simply do not see because this is just two-dimensional model. But there is equilibrium, interest rate, exchange rate associated with that model. And look, what does it mean for us is that now we know that these three functions above are defining three implicit functions. So income as a function of government spending, money supply, and world interest rate. Interest rate, equilibrium interest rate as a function of government spending, money supply, and world interest rate. And finally, equilibrium exchange rate as a function of government spending, money supply, and world interest rate. Right? But look, this is actually also allowing us to proceed to the next step. Because knowing that those are implicit functions and they are identities at the point of evaluation, we can rewrite the system that we had over here. Again, we can write IS curve as y minus c y d minus I as a function of equilibrium interest rate minus G0 minus CA as a function of equilibrium exchange rate and equilibrium income. And we know that this is equal to 0. Now, I can do exactly the same thing for LM. And I can do the same thing for BP. Okay. So, what do we do next? Well, in the next step, what we are going to do is to differentiate all those three equations. Okay, so again we start with IS. So we've got, okay, we already know more or less, we already differentiated it. So I'm going to make it in quick step. This is going to be 1 minus C prime, 1 minus T prime minus CAY, right? Times dy. Then we will have minus I prime d I and minus CAE d. I almost forgot. Yeah, and of course exogenous variable minus dg. Okay, now we move to LM. Your situation is simple. Ly d y plus Li d I minus dm0 equals to 0. And finally, the last equation, we've got CAE d E plus CAY dy plus KI d I and plus KIW d I w. Okay, so what should we do in the next step? Well, of course, in the next step, we will organize the variables. So all the endogenous variables go to the left hand, stay on the left hand side, exogenous we move to the right hand side. So we've got 1 minus C prime, 1 minus T prime, minus C A Y D Y. I hope I'm going to be able to fit it. Plus I prime D I plus C A E. I'm sorry, minus and minus. CAE d E equals to dg0. Over here we will have Ly d y minus plus Li d I equals to dm0. And finally, let's do it in the proper order. So we've got CAY d y plus KI d I plus CAE d E, and this is equal to, this is our only exogenous variable in the BP equation, so we here put it in with minus, so negative KIW d I w. Okay, and look, I hope you can see that at this moment we are ready to put this system into matrix notation. Okay, so we start with matrix of coefficients. Matrix of coefficients 1 minus C prime, 1 minus T prime, minus C A Y, L Y C A Y. Then we've got negative I prime, L I K I. Then we've got negative CAE, 0 CAE. Our endogenous variables, so they're differentials here. DI, dy, di, and DE. And finally here we just put all the exogenous terms, dg0, dm0, negative kiw, diw. And now we're ready. Look, what have we done? We've derived IS, LM, and BP. We found a Jacobian. Of course, we evaluated their slopes. we've calculated a Jacobian, so we know they intercept in one place. We know that equilibrium solutions are available. So we will be able to find comparative static derivatives. And this is the system of simultaneous equations that we are going to use for it. So the only one thing left is to analyze the impact of government spending, money supply, and world interest rate on equilibrium, income, interest rate, and exchange rate. This is going to be a topic of our next videos. Okay, thank you for your attention. And in the next video, we're going to analyze impact of monetary policy in this.